Hey, so what I'm going to be working on today is implementing this in-game Kelly Criterion. The Kelly Criterion gives you, um, if you know the probability that the event will happen, um, Kelly Criterion for betting. All right, blah blah blah. But if you're if you have a probability that an event's going to happen, and then the odds of the bet, the Kelly Criterion will give you spit out how much of your portfolio you should make on the bet. Blah blah blah. What's that? I don't know what any of that is. Here it is. So the amount to bet. Um, Here B is like I guess it's the decimal odds. I don't know if the decimal odds are B plus one. I think it's just B. And then B plus one is the amount that it's often represented as, because it's the amount you would win on a $1 bet. And then in America, they do it the amount you would win on a $100 bet. If it's positive, and then if it's negative, it's the amount you have to bet to win $100. So this is very simple. So B is the probability from the bet. P is the probability of it happening. Q, I believe, is the probability of it not happening. So just 1 minus P. And so from that, you get some percent that you should bet your portfolio on, some proportion of your portfolio to place on the bet. What I'm interested in doing is live betting, where you'll place one bet on one team, then you add a second bet on another team. Then, or the simple problem is, given a bet on a team, what are the odds that we should make the bet on the other team, and how much money should we place on the other team? And we want to develop a strategy where we're playing both sides of it as the game goes on. Okay, so the first step, it's going to be a complicated strategy, but the first step could be using this in-game Kelly Criterion here. So this is the simple Kelly Criterion. Not much to it. Very easy to find. This complicated Kelly Criterion is if you're holding multiple bets on the same thing. So the question is, how do we want to deal with the Kelly Criterion stuff? Risk manager. I'm trying to decide, do I want to start a new file, or do I want to put it all in here? Yeah, let's just make a new file. Oops, not text file. In game. In game. Kelly. Functions and classes for handling in-game Kelly Criterion optimization, because we have to optimize. All right. So we want to make this function g of f of t what is f sub t again? Is that the bet amount? All right. Define g of f is it redefined later? No. Okay. What's omega sub y? So I'm trying to figure out what omega sub y is. All right, what's y? What's IID again? Independent and independently. IID, independent outcomes. Independent and identically distributed. Okay. Following the notation in section 2. Okay, what's section 2? Let y denote a sequence of independent and identically distributed random variables for event I with y is either 0 or 1 such the outcome. I have a zit here. So the outcomes are independent and identically distributed. Okay. And omega sub y is just the space of the outcomes, right? Okay, so back to Kelly. Where's G? G. All right, so where? In a similar manner to the binary equivalent in equation 2.2, and as a special case of the in-game betting situation considered in the next section. Oh. Wait, so that's converging. So which G of F do we use? I have to find a song. All right. So we want to implement G. The question is which G? In a similar manner to the binary equivalent in equation 2.2. Since natural log of x is a continuous function. So we want to maximize the function subject to, but what G of All right, so what's the difference between these two? The difficulty of obtaining optimal fractions to wager depends on the complexity of the optimization problem stated above. We intend to show that this is an easy optimization problem in the sense that it is a convex problem, implying that any locally optimal solution is a global optimum. Okay. So then they show that it's convex. They give the problem. And then here we're going to show it's convex. Okay. Now what's different about this? Let it all work out. Let it all work out. They say you a side. Alright. Here we go. Date is 9/16/2024. Okay. So that's the second one. We go up to the earlier one. What's different? Maximize g of ft, subject to f is greater than or equal to 0. K is some element. Forgot what omega sub y are. Y is an outcome. Sum of fkt is less than... Oh, okay, so this is with all the restrictions imposed. And this has the epsilon term on the end. This is greater than or equal to epsilon now. Okay, so this is just kind of the final version. Okay. So now, let's put that over there. G All right, there's our G function. Now what's R? And what's P? P is the probability. Okay. Then we have R. Let it all work out. Let it all work out. Okay, so P doesn't come from anything, I don't think. Okay, let's check if anyone's commented, in which case we'll reply. Oh, I have to... Today I'm implementing the in-game Kelly Criterion from the paper we found last stream. Nice. Oops. Okay, and then timer so we don't miss anyone commenting. Nice. Okay, so we have P sub kt is given, R sub kt, now we have that. F is known, B is known. Yeah, okay. Okay, so the first thing to define here is define R. Sum from L equals 0 to t minus 1. Okay, let's try to describe this in plain language. The sum from all times from 0 to the instant before the current the sum of, and then in that, what's it the sum of? Bet amount times, what do you call those odds? Types of odds. American, decimal, ... Blah, blah, blah. I guess we'll just call it decimal. I don't know what terminology to use. Bet amount times decimal odds. So the payout. Oh, so that's just the payouts. The sum of all payouts minus the sum of all risk. Sum of all payouts. But you do it for each time. Sum for all times the payout, the difference between payout and risk at each time. Okay. Plug in my computer. All right, get the difference between the total risk and total payout. But what if you have different events? R sub kt. So what's the k? What does the k represent? Although the investment decision should ideally incorporate information about the expected path of probabilities until maturity, this is outside the scope of this paper. What does that mean? Although the investment decision should ideally incorporate information about the expected path of probabilities until maturity. Why do you have to care about the path of probabilities? Blah, blah, blah. Thus, the bettor is only allowed to take into account the amount already wagered when making this decision. What does that mean? A10. I don't even see that assumption 10 is ever given. To hang the phone up. Oh. The bettor is only allowed to take into account the amount already wagered when making this decision. Let me think while I go to the bathroom. The bettor is only allowed to take into account the amount already wagered. They're taking into the account the amount already wagered. But do they take into account how much they win? All right. So what does that mean? You can only take into account the amount already wagered, not the amount that we might win. Okay. Well, we could define R. Okay, let's go back to this because I'm not sure if this stuff's going to help us that much. Oh no. Did we have a problem with determined target odds? Let's get out of here. She's shallow. She's shallow. Okay, let's install the most recent version. And let's run it. Let's see, so... Okay, and then... Okay, so then we want to get the VIG free odds. Get VIG free odds. Assuming matches the vig equally distributed. Odds divided by odds plus 100 times 100. So the Packers are the favorite. Yeah. What? Okay. So we want to get the implied probability. Convert probability to odds. Convert odds. Okay, so then we do convert odds. Prob 1, prob 2 is equal to convert odds of odds 1. Convert odds of odds 2. And then we have okay, then we get then we could just return the probability that the favorite wins. VFP for VIG3 prob 1, VFP 2 is equal to prob 1 over prob 1 plus prob 2, comma, prob 2 over same thing, prob 1 plus prob 2. Okay. Equals. Oh, time to check the stream, see if there are any comments. Nope. True probability is whatever the maximum. Return true probability, and we could put the debugger in. Update the install. Trying to find a good song. All right. Here we go. Get vig free odds. Both are 100. Okay, so then the favorite, yeah, that makes sense. But I'm a creep. I'm a widow. What the hell am I doing here? Okay, and then risk management. Instead, I just want to convert odds. Okay, yeah, so if it's minus 140 is telling us 58%, plus 170 is telling us 37%. The true amount, true probability, 61% for the favorite. Okay, so we've got that. Now what do we want to do? I guess the question is, so what would be the vig free odds if we're holding? I don't know what to, we need to develop some terminology because I don't know what to call it if we're holding positive bets on both teams, but so then it's just 50%. I don't know what the point of calculating the vig free odds are. I kind of forgot what I was trying to do. Okay, so now if we go to determine target odds, man, how do we figure out the odds we want? So we could add bets, we could know our risk. The higher the risk associated with an investment or decision, the higher the expected return should be to compensate for that risk. Conversely, a low risk investment will have a lower expected return. We have to consider both risk and expected value. So we could just try a bunch of different things. See what raises expected value. If we don't want to add any more risk, so we have a metric on expected value, but how do we get a metric on risk? Expected value takes risk into account, but doesn't solve our problem. Portfolio's return the higher the risk associated, yeah. Risk cannot be eliminated entirely. It can be managed by diversifying investments and making informed decisions, but it can be eliminated entirely. If we get to a point, there's always risk on the initial bet, but once we place a second bet, we can totally eliminate risk. What do you do when there is no risk? You need to maximize expected value somehow while minimizing the risk that you take on. Probability is a measure of the likelihood or chance of an event occurring. It is expressed as a number between 0 and 1, where 0 represents an impossible event and 1 represents certain. All right. Can we treat bets/events like stocks and simply resize/adjust our portfolio at each time? You need so with a stock you have a certain amount tied up at a certain time. With a bet you also have a certain amount tied up, but you can't exit it. That money's locked. Until you get it out. Can we treat bets/events like stocks and simply rephrase? I don't know. Betting risk refers to the potential loss that a bettor may face when placing a bet. This risk is usually associated with the unpredictability of sports events. How do you define your risk? That's what I'm wondering. Do you just define it as the amount that you could lose? Oh. Risk has to do with probability that something will happen. It seems like risk is taken into account by expected value. Yeah, I get that. So how do you weigh the two? The probability to lose X amount of money or more in the following period is piece percent. Yeah. Now, what does that mean? Max risk. So 780 on here. So is it 280, 330, 430, 290, 490. Yeah. So what does that mean? If you win 420 but risk 780, right? So 60. What is 290? Where does that number come from? I gotta pee again. Buddy, come here. Buddy, come here. All right, check. We have any comments? Nope, we're good. Oh, is the screen moving? Oh crap! It hasn't even been streaming anything this whole time. Yeah. Okay, I'm just gonna stop this then.